Going to be looking at our final topic for this trig unit, and in this lesson we're going to be solving problems with more than one triangle. Let's take a look at our learning targets. By the end of this lesson, you should be able to solve problems involving more than one right triangle. Before we get into our examples, let's just do a quick refresher of our trig ratios. Remember that we can remember our ratios using a mnemonic device called SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Remember that whenever we have two side lengths and we're looking for a third side length in a right triangle, we can use the Pythagorean theorem. Always double check that your calculator is in degree mode, and remember that there are 180 degrees in a triangle. When it comes to solving problems, we're going to have the same process over and over. You're going to sketch a diagram if needed, label your triangle, set up your ratio, and solve. And then when it comes to rounding conventions, remember that unless you're told otherwise, round your lengths to the nearest tenth and your angles to the nearest degree. The process for solving multi-triangle problems isn't much different than what it was when we had single triangle problems. The only difference is that now we have more than one step. Often when we're working with multi-triangle problems, our goal is to find the shared line. So there's often going to be some information, but not enough information. We have to figure out what we have, what we need, and what we need to do to get there. Example 1 says that while on vacation, a couple decides to climb a cliff overlooking a river. In planning ahead for the climb, they hire a surveyor who takes some measurements to calculate the height of the cliff. From point P across the river, the angle of elevation to the top of the cliff is 43 degrees. So our angle RPT would be 43 degrees. From a point S 30 meters down the river, angle TSP is going to be 68 degrees. So that's going from across the river to the S to the P. Using this information, we're asked to determine the height of the cliff. Now, if we wanted to find the height of the cliff using that triangle RPT, notice that we have an angle 43 and we're looking for the height. In order to remember, whenever we're working with our trig ratios, there's three pieces of information, but only one of them can be an unknown. We're looking at our triangle, our height is unknown, and we have an angle of 43 degrees. Right now, we don't have enough information to determine that height. So we're going to look at another triangle and see if we can use that triangle to find the piece that we're missing. If I have 68 degrees and 30 degrees, notice there's a shared line between these two triangles. Well, I can find this length PT, and once I have that, then I can find the height H. Always, we're going to start with labeling our triangle. I have 68 degrees. Across the triangle is my opposite, and beside the angle is my adjacent. So I know my adjacent, and I'm looking for my opposite. That means I'm going to be using tan. So tan of the angle, tan of 68 degrees, is opposite, which is x, divided by adjacent, which is 30. Since I'm looking for the x, I'm going to be cross-multiplying 30 times tan 68. Calculator, I'm first going to double check that I'm in degree mode. And then I'm going to go 30 times tan 68. Now that length is 74.2526. Rounding to the nearest tenth, I'm going to have 74.3. Using that new side length, I can relabel my triangle. So my height will be opposite, and the 74.3 will be adjacent. Once again, I'm working with opposite and adjacent, so my ratio will be tan. So tan of 43 degrees will be opposite, which is h, divided by adjacent, which is 74.3. Now it's important to note that on my paper, I've rounded my length to 74.3, but when I'm using my calculator, I'm going to keep that number exact. So to get h by itself, I'm going to take 74.3 and multiply by tan 43. And that would give me 69.2 meters. If I had used my rounded value, 74.3 times tan 43, that would have given me 69.2858 and so on, and that would have rounded to 69.3, and I would have had a rounding error. Not all of the time will this be an issue, but the more calculations we do with measurements, the more likely it is that we're going to encounter rounding errors if we don't keep our numbers exact on our calculator. So in part B, we're asked to determine what the slope would be if a zip line was built from the top of the cliff to point P. Well, the formula for slope is rise over run, which is our vertical distance divided by our horizontal distance. In this case, our vertical distance is 69.2 and our horizontal distance is 74.3. Now again, these are both rounded values, so we want to try to keep those numbers exact in our calculator. I already have the 69.28, so I can just hit the divide sign. If this was a TI-84 Plus, I could just arrow up and bring that number down. With this calculator, it's not quite as easy. I could store the value, but right now it's probably easier just to type in the number as I see it. And that will give me 0.93. The slope of that zip line would be 0.93. Example 2 says that a building is 32 meters tall. At one position from the base of that building, the angle of elevation to the top of the building is 81 degrees. And at a position 4 meters further away, we're asked to determine the angle of elevation. Let's get started by sketching a diagram. First of all, we know that we have a building, and that building is 32 meters tall. We also know that from a point that's a certain distance from the building, we have an angle of elevation of 81 degrees. And then if I walk 4 meters further away, I'm being asked to determine this angle of elevation. So I can label that as 4 meters. If I were to walk further away from the building, should my angle of elevation get bigger or smaller? It will get smaller. And now it's important to ask ourselves those questions because as we work through these problems and we get an answer at the end, it's always important to ask ourselves, is it realistic? Does it make sense in the context of the question? So if we were to get to the end and have an answer that's bigger than 81 degrees, we know that we've probably made a mistake somewhere. Ultimately, we're being asked to determine that angle of elevation, so I'm just going to sketch a separate triangle. We don't know what this angle is, but we do know that we have 32 meters and we also have our 90 degrees. Right now, I do not have enough information to determine what that angle is, but I do have enough information to figure out this side length. Remember that whenever we're working with multi-triangle problems, a lot of times we have to look for a shared side. So we're going to start off by labeling our triangle. Across from the 81 degrees is opposite, and I'm going to be looking for this side length, which is adjacent. Once again, I'm using the tan ratio. So tan of 81 degrees is 32 meters divided by x. In this case, to solve for x, I'm going to be dividing 32 by tan 81. Calculator, I have 32 divided by tan 81. And that's going to give me 5.068. Again, I'm going to round on paper, but I'm going to keep it exact in my calculator. Now, in order to know this side length here, I need to know this total distance here. So that means I'm going to be adding 4 meters to the amount that I've already calculated. That's going to give me a total length of 9.068 meters. Now I have enough information to determine that angle. Labeling my sides, I have opposite and I have adjacent, so I'm going to be using the tan ratio. So tan of the angle is opposite, which is 32, divided by adjacent, which is 9.068. And in order to determine my angle, I'm going to be doing the inverse of tan. So first of all, I'm going to add the 4 so that I have my 9.068, and then inverse tan of 32 divided by second answer. So I'm just bringing that answer down. Again, on a TI-84 Plus, you could just arrow up and grab that number. That's going to give me an angle of 74 degrees. Now that number is smaller than 81, so I know I'm probably on the right track. Example 3, we're asked to determine the width of the river. Well, if I look at the right triangle, I have a 70 degrees and I have an X. I don't have enough information. But on the left-hand side, I have a 15 degrees and a 420, so this would give me enough information to determine the width. I start by labeling my triangle, so X will be opposite, 420 will be hypotenuse, so we're going to be using the sine ratio. That gives us sine of 15 degrees is opposite, which is X, over hypotenuse, which is 420. To get X by itself, we're going to be multiplying 420 times sine 15. My calculator, 420 times sine 15 gives me 108.7. Part B, we're asked to determine the distance from A to C. Well, we can start by using our 15 and our 420 to find this length, and then we can use the 108.7 that we've just found and the 70 degrees to find this length, and then we can combine them together. Again, we'll start by labeling our triangle. We're looking for X, which is adjacent, and we have hypotenuse. So in this case, we're going to be using the cosine ratio. So cosine of 15 degrees equals x divided by 420. And on my calculator, I'm going to be going 420 times cos of 15, which gives me 405.7. I'm going to start by labeling my second triangle. So across from the 70 degrees is opposite and y is adjacent. So in this case, we're going to be using the tan ratio. I would have tan of 70 degrees is opposite, which is 108.7, divided by adjacent, which is y. If you notice on my calculator, I don't have that 108.7 anymore, so I'm just going to start by redoing that calculation. So 420 sine 15, that's going to give me my exact value, and I'm going to take that number and divide by tan of 70. And that would give me 39.565 or 39.6 meters. My final step is to add those two amounts together. Again, on my calculator, notice that that 405 is a little bit further up, so I'm just going to hit the plus sign and then type in that number. And that's going to give me 445.3. Total will be 445.3 meters. Example 4, we're told that a non-standard roof on a house has one side that is 18 meters long and the other side is 23 meters long. The peak is 14 meters high. We're first asked to determine the angle formed at the peak, so that's going to be both of these angles combined. In order to do that, we're going to have to find the angle formed between 18 and 14 and the angle formed between 14 and 23. Again, we start by labeling our triangle. So we're going to have 14 is my adjacent and 18 is my hypotenuse. For angle y, 14 is also my adjacent and 23 is my hypotenuse. So in both cases, we're going to be working with cos. So cosine of x would be 14 over 18 and cosine of y will be 14 over 23. Remember, we only use the inverse when we're looking for an angle. So we're going to do inverse cos is 14 over 18. That gives me 39 degrees. And then the inverse cos of 14 over 23 will give me 53 degrees. Get the total span of the roof, we're going to just add those two numbers together. And that gives me 91 degrees. Now, if we're asked to determine the span of the roof, that means we're looking for the total distance from one point to the other. Finished determining some angles, so we can absolutely use those to determine our unknown side lengths. However, if we made a calculator error, that would carry through to our next step. So if we can use information that's already been given to us, that's usually our best step. Notice I have two side lengths and I'm looking for a third side length, so I can use Pythagorean theorem, and the same would apply here. So A would equal the square root of 18 squared minus 14 squared. And for B, I would be looking at the square root of 23 squared minus 14 squared. Again, I can go to my calculator. We'll take the square root of 18 squared minus 14 squared. And that gives me 11.3. And then for B, the square root of 23 squared minus 14 squared is 18.2. Adding those together, that would give me 29.56, which rounds to 29.6. So there's 3 questions here. I'd like you to choose at least 2 of them, pause the video, try them on your own, and then come back and check your work. Now for part A, we have a cell phone tower that's being supported by 2 guy wires or 2 support wires that are each attached to the ground 3 meters from the base of the tower. The angles of elevation for each guy wire are 46 degrees and 34 degrees. We're being asked to determine how much higher up the cell phone tower one guy wire is than the other. Sometimes it's helpful when we're doing these questions to redraw our triangle so that we don't have everything as one big diagram. Notice with the triangle on the left, my angle of elevation is 34 degrees. we have a horizontal distance of 3, and we're looking for the height, which is A. We can labeling our triangle, we have A as opposite and 3 as adjacent, so we can use the tan ratio. For B, we have 46 degrees, the height is our opposite, and the horizontal distance is our adjacent. So once again, we're using tan. Now don't be surprised when we're working with these multi-triangle problems that tan does pop up quite a bit. That's quite common, so don't be surprised if you see tan a little bit more often. Setting up our ratio, I have tan of 34 degrees is A over 3, and then my other ratio will be tan of 46 degrees is B over 3. Calculator, I can go 3 times tan 34 will give me 2.02, and then 3 times tan 46 will give me 3.1. Being asked to determine the difference in their heights, so we just need to subtract. And that's going to give me 1.08. Rounded to the nearest tenth is going to be 1.1. He says that from the top of a 350-meter tall building, the angle of elevation to the top of another building is 52 degrees, and the angle of depression to the bottom of the second building is 60 degrees. And then we're asked, how tall is the second building? Well, we already know that part of the building is 350 meters tall, but we need to know the remaining piece so that we can add them together. So we're going to look at our 52 degrees. With 52 degrees in H, I don't have enough information to determine the height. So I'm going to have to look for a shared line, and that's going to be the distance between the two buildings. Redrawing my triangle, I'm going to have a height of 350 meters, an angle of 60 degrees, and we're looking for that shared side. Labeling my triangle, I'm going to have opposite and adjacent, meaning I'm going to use the tan ratio. So tan of 60 degrees equals 350 meters divided by x. Calculator, I'm going to go 350 divided by tan of 60, and that's going to give me 202.1. Again, I'm going to keep that number exact on my calculator. Now that I have the 202.1, I can redraw my triangle. I'm looking for height. I have 202.1, and I know my angle of elevation is 52 degrees. Filling my triangle, I'm looking for opposite. I have adjacent, so I'm going to use the tan ratio. Tan of 52 degrees is opposite, which is h, divided by adjacent, which is the 202.1. On my calculator, I can multiply times tan 52, and that gives me 258.6. Now we take a look back at our question to see what we were trying to find. We're being asked to determine how tall is the second building. Well, we know that the bottom part is 350, and we've just determined that this height is 258.6. So we're going to add those two together. And that gives me a height of 608.6. Now, a common mistake that I see some students make is that they would add the 202 and the 258. We get so busy finding these numbers and then we just think we have to combine them together that we don't pay attention to what they represent. We only needed the 202 so that we could get the distance between the two buildings and use that to find our height. But ultimately, because we're being asked to determine the height of the building, we need to add the 350 and the 258.6. C, we're told that a person is standing 275 feet from the base of a building. The angle of elevation to the base of the tower's antenna is 32 degrees, and the angle of elevation to the top of the antenna is 42 degrees. And then we're asked, how tall is the antenna? Well, this question is very similar to the one that we did in part A. Working with overlapping triangles, sometimes it's helpful to redraw our diagrams. So we're looking for x, so that would be our opposite, and we know 275, that's our adjacent. For the other triangle, we have an angle of elevation of 32 degrees. We're looking for y, which is our opposite, and our 275 is adjacent. Once I have those two amounts, then I can subtract to find the height of the antenna. So setting up our ratios, we're going to have tan of 42 degrees is opposite over adjacent. And for the other triangle, tan of 32 degrees is opposite over adjacent. On our calculator, we're going to go 275 times tan of 42, and then 275 times tan of 32, and that I'm trying to determine the height of the antenna, so I'm looking at the difference between these two numbers. So on my calculator, I'm going to have that 247.6, and we're going to subtract the 171, which is 75.8. Again, it's important that we always remember to keep our values exact in our calculator and only round at the very end. If you're feeling extra confident about your trig skills, take on this challenge. A rancher who lives near 100 Mile House, BC, is planning to build a new fence around his property using 3 strands of barbed wire. Using this information and the diagram of his property, how much wire will he need for the fence? Pause the video, try it out, and then come back and check your answer. So let's take a look at this question. In order to figure out the perimeter of this fence line, we're going to need to find A and B. And in order to do that, we're going to have to find some other pieces. So what I started doing was looking at what Y and X would be. So cosine of 60 would be X over 200, which would give me this value here of 100. And then sine of 60 was Y over 200, and that tells me that this length here is 173.2, which would also correspond to this length out here. In order to find the other part of this length, I could use cos 50 is W over 500, and that's going to give me a length of 321.4. Again, these values are rounded on paper, but I would have kept them exact in my calculator. Those two together would give me the total length of B. Now the last piece is to figure out A. We already know that this portion here is 100, so we just need to figure out the remaining portion here. We know that this portion here is 100. If I find the whole length and subtract 100, I would know what A is. So I can do sine 50 equals Z over 500, multiplying that will give me 383. So if the full distance is 383, when we subtract 100, I know that this distance up here will be 283. So once I've labeled all of my sides, I can total up my perimeter, and that total is going to give me 1,477.6 meters. But that's not my final answer. We're told that in order to build the fence, we need 3 strands of barbed wire. So we're going to have to multiply that amount by 3, which will then give me 4,432.9 meters. Now, if I were to divide that by 1,000, that would tell me that I'm looking at approximately 4.4 kilometers of fencing. That's a lot of fencing. It gives you a number of examples related to multi-triangle problems. What I'm hoping you recognized is that the process is still the same. We're always labeling our triangle, setting up a ratio, and solving. When it comes to working with more than one right triangle, often we can use some strategies like looking for a shared line, redrawing our diagrams, especially if one triangle is embedded into the other, and we always try to determine what our end goal is, figure out what information we have, and then work backwards to see what we need to start with. All right, guys, hopefully that gives you enough practice. Have a great day, and we'll see you soon.